Hi. Let's start with chapter 3, the Boolean algebra. So we will cover a lot of things for the chapter 3, the introduction of this, and some basic logic gate, NOT gate, logic OR, logic AND, some truth table. We look at some Boolean expressions and some Boolean theorem as well. And we also look at some the universal NOR gate or NAND gate. Alright, this is such a long chapter. We have a look at that. Now, okay, this one, the fit the light logic, what are they talking? The door and the light, right? So let's say maybe the door is open, the light will turn on, right? So we can see that, you can see that here, my friend. The door, okay, the light, you can, okay, here. The light is a function of the door, depends on whether the door is open or closed, right? Have a simplified aircraft takeoff logic system. You can see here, right? This is what visibility, aircraft conditions. If both condition okay, the pilot can see clearly in front, and the aircraft condition is good. Yep. Can take off signal will, let's say, turn on, then the pilot can, you know, can take off the flight. So we can see that the takeoff signal is a function of, depends on this visibility and also the aircraft conditions. So takeoff is depends on these two conditions. Boolean equations, alright, okay. If we are talking about input and output, right? Input conditions and the output conditions, right? The output depends on the input, right? So they are talking in general is a mean to express the relationship between the logic circuit output and input. We look at it in more detail. There's a Boolean variable, right? Okay. We can say, okay, the output X is depends on ABCD. Okay, in layman term, the function, the output Y also depends on ABCD, right? Boolean algebra, all right. We are talking about two possibilities, 0 or 1, right? Either true or false, on or off, high or low, yes or no, open or closed. Nothing more than that. You can see from here. Logic OR, right? Logic OR operation. What is logic OR operation? What is logic AND? What is NOT operations? All right. The circuit that carry out elementary operation is known as gate. All right. Condition satisfied, they open the gate for you to get through. Condition not satisfied, the gate will be closed. As simple as that. Right. Look at the first one then. This is called inverter. First one is called inverter. Okay. A input, let's say A, this is the output. Okay. Input here is 0, output will be a 1. Dobale, right? This is an inverter. That means everything is opposite. If here 1, here 0, here 0, here 1. Nothing more than that. Boolean equations. So I always tell my student, let's say, like this. Dobale, right? Nothing more than that. Everything is Dobale. So we can write, let's say if this guy, the input is A, so the output will be Dobale. Let's say the input here is A, right? Input here A. Output here will be also A, but it's theoretically is what, A Dobale, right? But we cannot write like this. So what does it mean? So you write A, got a bar on top. That means to show is inverted. That's what it means. Right, so you can see output X is going to A got a bar on top, right? What it is? Got a 2 bar on top, right? That means check it out. Okay, like this, and then invert it one more time, right? Show you A, right? This guy got a bar on top. Okay, this is A. This guy bar on top. That means Dobale, right? So we invert again. That means we put another bar on top, right? Correct or not? But what happened? This guy input like that, right? So the output will be. Can you see that? So you've got a double bar on top. They say is as good as no bar on top, right? Cut the long story short, as long as the bar on it like this, or double 1, 2, 3, 4, or as long as the number bar on top A is even number, is as good as A. Understood? Nothing more than that, right? Logic OR. OR that means either you or me, right? Either you or me can already, okay? Now, check the truth table. We list all the possibility. 0, 1, 2, 3. You know by this sign total possibilities that this guy 2 to the power 0, 2 to the power 1, right? Right. So this guy, we list all the possibility 1 and 2. So it's 0, 1, 2, 3. No issue, right? You know all this already by now. So the output is like this. We list all the 2 input possibility. As long as one of the input is a 1, the output will be 1. As simple as that. You see that? 0, 0, 0, 1, 1, 0, 1, 1. Right? Put in equations. Right. So we rewrite A plus B. Plus is a logic OR. Plus is a logic OR. Plus is logic OR. Okay, A plus B, A or B. Alright, so we write down Boolean equation is A plus B. Check this one now. Then you say this glass is half full or half empty. Describe the situation fully. This is because there can be only 2 possibilities, either full or empty. Right. Likewise, in the case of logic circuit, for logic circuit, alright, the output can either be 1 or 0. That means have or don't have. Okay. Complete of this Boolean equations.